Hello and welcome. On behalf of CDS, I would like to welcome you all to the course Remote Sensing and GIS for Environmental Studies. So my name is Dr. Ermias Teferi. I'm going to be your guide, your instructor, your facilitator as we learn, explore in the course. So before we dive into the course Remote Sensing and GIS for Environmental Studies, I have to explain the reason why I prepared this video lecture. I've prepared this video lecture particularly to postgraduate students in response to the COVID-19 impact on face-to-face learning that's going on at Addis Ababa University. So AAU's response to the COVID-19 outbreak is focused on protecting students and staff members to minimize the potential for the virus to spread. All staff are in fact working from home, and we are adhering to the government advice on social distancing and travel restrictions. So we are also working on ways in which we can blend online teaching with face-to-face learning by ensuring that the teaching learning activities are compliant with the latest government guidance. So I wish you a very pleasant stay with me as we go on learning about remote sensing and GIS for environmental studies. Now let's continue. We'll start from lecture 1, that is about basic concepts of remote sensing. We'll start with definition of remote sensing. So what is remote sensing actually? So you will find many definitions of remote sensing in many textbooks. So, but there are key terms that we usually use in defining remote sensing. So one of the well-known definition that is given by Lelisand and Kiefer is given here. Remote sensing is an art and or a science of obtaining information about an object or feature without having physical contact with the object or with the area or with a thing under investigation. So this is a general definition. So in this definition, there are very important words. It's an art as well as it's a science. So it incorporates, the issue of, art and the issue of science. We call it science because remote sensing is based on mathematics, based on physics, especially based on radiation principles, based on electromagnetic principles. Another keyword in this definition is it's all about obtaining information. Getting information from a distance without having any physical contact, okay, with help of electromagnetic radiation. So the question in here that we ask is, how can we obtain information without having any physical contact? The answer is, with the help of electromagnetic radiation, one can acquire or obtain information from a distance. Okay, so this is a general definition of remote sensing. So here is one pictorial, example of remote sensing. This is an example of a passive remote sensing. It all starts from an energy emanating from the sun. This is the sun radiates energy propagates through the atmosphere, when an electromagnetic radiation passes through the atmosphere, it doesn't simply pass through the atmosphere, but it interacts with atmospheric particles. So as a result of the interaction between electromagnetic radiation and atmospheric particles, there are different mechanisms of interaction. Some of the energy will be absorbed, scattered, and transmitted through the atmosphere. The transmitted energy will be able to reach the surface of the Earth and forms interaction with Earth's object. And another form of interaction will be created in here and in C. There are three forms of interaction that is created when the electromagnetic energy interacts with Earth's object. These three types of interactions are reflection, transmission, and absorption. Okay, the reflected energy will be reflected and sensed by the satellite sensor. Okay, and there are also other satellites which may send signal to Earth objects. Okay, but in passive remote sensing, we follow this path. So the reflected signal from Earth's object is going to be sensed by the satellite sensor to be recorded, measured. Okay, and this recorded and measured signal will be sent to the ground receiving station for further processing. Okay, or this recorded signal may be sent to another satellite for further processing. Okay, once it reaches the ground receiving stations, it is going to be processed, okay, in the form of tapes, digital medias, for the further production of maps, tables, statistics, and the like. So having looked at this pictorial representation of remote sensing, one can define remote sensing by saying it is a process of inferring surface parameters. Surface parameters mean the vegetation height, vegetation canopy size, and the like, from measurements of the electromagnetic radiation from the Earth's surface. So why do we study remote sensing? This is very important question that we need to ask before we dive into the subject remote sensing and GIS for environmental studies. There are a couple of reasons that you can find in textbooks, the reason why we learn remote sensing. The first reason is because it gives aerial perspective. Okay, it gives a large coverage data at global scale, at national scale, at local scale such as Woreda scale, zonal scale, and regional scale. Data can be obtained through remote sensing. So remote sensing covers a wide area, so you can collect information at a time for a very wide coverage. The second reason why we learn remote sensing is remote sensing gives you an advantage of documenting change. This change could be historical urban expansion, historical land use, land cover condition of a certain area. That could be an agricultural landscape, that could be urban landscape, that could be forest landscape. This is a very good advantage of remote sensing. The best, data sets that we use in remote sensing to document change is Landsat satellite images, which started from the year 1972 up to the current land condition could be depicted by the satellite image series. The third reason that's why we study remote sensing is because we can obtain knowledge beyond our human visual perception through remote sensing. Our knowledge thanks to remote sensing, our knowledge is now extend beyond our human visual perception. Most of the time you hear that seeing is believing. Seeing with human eye is only limited by your eyes, and the electromagnetic radiation that is applicable for human vision is visual electromagnetic radiation. It's called a visual range. Human eyes usually work or operate within the range of visual or visible range. This visible range ranges from 0.4 micrometer wavelengths up to 0.7 micrometer wavelengths. Okay? So our knowledge, if we rely on this visible range only, our knowledge can only be limited by this range, 0.4 up to 0.7. But there are a lot of issues that are going on beyond the human or beyond the visible range of electromagnetic spectrum. So how can we understand those issues that can be visible out of the visible range, such as infrared, such as microwave, such as X-ray, such as ultrasound, such as there are so many wavelengths ranges with which we can explore a lot of issues that are going around us. So remote sensing gives you knowledge beyond our human visual perception. And the fourth issue why remote sensing is important is because remote sensing helps you extract information. This information is three-dimensional terrain characteristics can be extracted in a minute as a result of remote sensing. The best example for this is SRTM digital elevation model is a terrain data. So we are now able to compute the slope of the whole world in a minute, the digital elevation of the whole world in a minute. It is because remote sensing gave us this kind of opportunity. Another information that is useful to extract from remote sensing is land use, land cover. You have so many other biophysical parameters that can be extracted, such as leaf area index. And there are other biophysical as well as any other parameters or information that can be extracted. So these are a couple of reasons why we study remote sensing. Now look at this. We are able to obtain knowledge beyond our human visual perception. We have said that earlier. This is a whole range of electromagnetic spectrum, which ranges from gamma ray all the way down to radio waves, microwaves, and the like. There is a small portion which ranges from 0.4 up to 0.7. This is in nano, but I'm talking in micrometer. So this is a very small portion of the whole range of electromagnetic spectrum. And this is a portion where human eye, can operate. Very small portion, How can we say seeing is believing? Recognizing this fact. There are a lot of wavelengths ranges that cannot be detected by human eyes. But we cannot deny their existence, even if we are not able to detect them. Okay? In order to detect those activities that are operating out of this range can be detected by devising a special sensor. Look at this, for example. This is our sun. The sun has got its own diameter, its own size. Our sun cannot be visible, cannot be detected by human eyes. Why? Because the electromagnetic energy of the sun cannot be detected by human eyes. It's not within this range. In order to visualize our sun, we need to be able to develop a special sensor that can operate within this range, which is most of the time thermal range. Okay, now we are able to measure the diameter of the sun, okay, the size of the sun. We are able to predict the existence of the sun, okay, because of remote sensing. Another, knowledge beyond human visual perception is, we are now able to locate people inside a lorry. We are now able to elicit drugs. We can detect drugs inside a big lorry. We can also detect explosives. Okay, these are not detected by human eyes unless we devise a special X-ray sensor, thanks to remote sensing. Remote sensing gives you knowledge beyond human visual perception. These are some of the examples. I can give you a lot of examples. If you go to clinic, you will find ultrasound. Ultrasound is also a device which helps you have, a picture of your baby, okay, without having or without your visual, perception. Okay, ultrasound is another example. You have so many examples. Okay, and there is a relationship between remote sensing and other, geosciences, to mathematics, to GIS, to cartography, to social science, to physical science, to biological science. Remote sensing has this position. Okay, and limitation of remote sensing, we don't want to oversell the advantage of remote sensing. We have to tell you the limitations of remote sensing. One of the limitations of remote sensing is the interpretation of the satellite imagery requires a certain skill. The way you extract information, differs from person to person, depending on the skill of the expert. Okay, and another issue is remote sensing needs cross verification with ground truth data. Okay, there is a saying called remote sensing without field verification is non-sensing. That means remote sensing always requires field verification or field data. And another issue is data from multiple sources may create confusion. Okay, so you need to be very much skillful to extract or to be able to extract information from multiple sources of remote sensing. Okay, objectives, because of different reasons, objectives can be misclassified or confused, and distortion may occur due to relative motion of sensors. These sensors could be mounted on aircraft, on satellites, or on drones. So the relative motion of the sensor and the source could create some kind of distortion. Okay, where do we put our remote sensing data from or in the continuum of our research process, from statement of the problem, data collection, conversion of data into information, and information presentation? This is a whole process of problem solving. Where do you put your remote sensing process? Remote sensing can be categorized or can help your problem solving process in collecting data as well as in conversion of data into information. Okay, now let's come into the very basic principles of remote sensing. So 1.3 is electromagnetic energy and remote sensing. Knowledge of electromagnetic energy is needed in remote sensing for two reasons. The first reason why we have to know electromagnetic energy is because this knowledge helps you understand the principle of remote sensor. Okay, for example, our eye is an example of a remote sensor. Okay, it operates within a certain wavelength range, which is 0.4 up to 0.7. So we came to know this visible range and the principles of our vision because we have understood the basic principles of electromagnetic energy. Likewise, in remote sensing, there are many remote sensors. In order to understand how do they operate, how do they function, we need to be able to know electromagnetic energy. The second reason why we have to have a knowledge on electromagnetic energy is to interpret remote sensing data correctly. Okay, this is another very good reason. In order to understand electromagnetic energy, we have two models: wave model or wave theory and particle theory. Or electromagnetic energy can be modeled in two ways: by wave or by particle. Okay, what does wave theory say? Wave theory says, assuming a sinusoidal wave or a sinusoidal model moving at a fixed wave speed. This speed is speed of light. It is fixed, it is constant, it is c. Wavelength is inversely proportional to frequency. Okay, from wave theory we can put this theory in terms of c wavelength. C is speed of light, wavelengths, and frequency. Okay, since this is constant, if you extract frequency, you can have c is the speed of light over wavelengths. Now, from this equation, you can understand that there is inverse relation between frequency and wavelengths. So what does wave theory say? It says there is inverse relation between frequency and wavelengths. Okay, waves with higher frequency have shorter wavelengths, and lower frequencies have longer wavelengths. So this is the general understanding that we get from wave theory. Okay, electromagnetic energy is composed of electrical energy and magnetic energy. Okay, both electrical and magnetic energy are oriented at 90 degrees, propagate in a sinusoidal fashion that goes with a speed of light c. This is c. Okay, so this is generally what wave theory say. And the second issue, now let's have a detailed explanation about wave. Wave can be explained. Wave has its own amplitude, its own time, its own period. Okay, so the time required to complete one cycle is called frequency. Okay, so how fast is a wave is determined by the frequency. Okay, if you see this, the number of frequency is different. Okay, this is slow and this is medium and this is fast. Okay, the amplitude tells you the height of this wave. Okay, the period tells you the frequency. So normally 1 over t is frequency. So from particle theory, we can understand that the energy of a quantum is considered to be proportional to the frequency. The energy of a quantum, Q, is proportional to h Planck's constant times frequency. Okay, this is directly proportional. Okay, we know from our previous wave theory, frequency is inversely proportional to wavelengths. So if you relate energy of a quantum with wavelengths, you will find there is inverse relation with wavelengths. Okay, take a look at this figure. So this is a short wave. Short waves are associated with high frequency. High frequency is associated with high energy. High frequency and energy are related based on particle theory, while frequency and wavelengths are related based on wave theory. Okay, if you go on to long wavelengths range, such as radio waves, TV waves, you'll find lower frequency and lower energy. Okay, but at short wavelengths such as X-ray and gamma ray and cosmic rays, the energy associated with such wavelengths radiations are very much high, and they can easily damage our health because they are stronger. Okay, because of particle theory and wave theory, we have now some clue about the energy and the frequency associated with wavelengths. Okay, now let's have a look at the whole range of electromagnetic spectrum, which ranges from cosmic ray, gamma ray, X-ray, ultraviolet, visible, near infrared, middle infrared, thermal infrared, microwave, television, and radio waves. These are longer wavelengths, these are shorter wavelengths. The energy associated with these ones are high and strong. The energy associated with longer wavelengths are very low energy, low frequency, but the wavelength is longer. Okay, we can divide the whole range of electromagnetic spectrum by saying thermal energy and reflected energy. Reflected energy are most of the time short wave infrared, while the thermal ones are longer wavelengths infrared. Okay, those category under shorter wavelengths are middle infrared, near infrared, visible ranges. So the visible range is a range where our eyes can operate. Okay, blue, green, red. There is UV rays and near infrared rays. Okay,